Our central air unit is called Advantage. It comes in this gunmetal gray color, exactly how you see it. Out of the box, the warranty is 10 years. Out of the box, but we still recommend having it registered. Be careful. Perfect, perfect. It will come with a liquid dryer, and I do recommend you installing it inside where the air handler is. Take it out of the element because that's going to rust on you. That's where you're going to have your leaks. Also, too, it's going to come with these two liquid and suction line fittings, because you'll see our service ports are not braze; they're flared, just like the multi-ports. Aluminum coil, right? Here's your circuit board. You bring your power source here. Your transformer is way back here. This is the panel you take off to slide in your electric strip heaters. If you can see with the motor, there is no plugs on the motor. It's hardwired right into the motor, which I like that because inside this cabinet it gets really cold. The dew point changes and you're going to have a lot of condensation in there. By wiring it like this and making it seal tight, you reduce the module failures because of condensation, which I like that. So the connections are all going to be right here on the board.
Wire connection to or braze?
This is braze. Now, at the air handler is braze. At the condenser is where it's flared. I do recommend you installing, or along with the surge protection. It doesn't have built-in surge protection, but what it does have is current sensing protection, and it'll have what they call a noise filter, which is it cleans the AC sine wave, the voltage that is attached to it. It'll have that, but it doesn't have surge protection. So that's something you would sell separately, and I do recommend, because of the boards, I do recommend you adding that to your proposal. Fully 4 different positions on this air handler, so we'll go through the slides. So it is multi-positional. All right, there are 2 different ways where you can control it. Well, we're going to talk about that. We can use our communicating thermostat, or you can use a 24-volt thermostat. You would set the dip switches on the indoor and outdoor unit. So if you're going to use communication, you set the dip switch to let it know it's going to be communicating. You're going to use 24 volts, you set the dip switch for 24 volts. Okay? Same thing if you want to, it's a heat pump, but you can use a dip switch to operate as a straight cool unit only. All right? That's where the dip switches are for outside. We'll go through that as well. This is just basic information where, as far as how an inverter works. Why is the industry going into the inverter technology? Well, for the most part, what makes it efficient is that it has all these thermistors located on the outdoor and indoor unit, and it's also registering your temperature outside as well as inside. And finally, it will also time itself to see how long does it take to satisfy that thermostat. It's gathering all that information. And that's how it adjusts its speed. That's how it adjusts itself. It changes hertz, and that's how it changes speed. And as a result, so you have 230 volts connected to it, but we're not going to be using the full 230. We could be running at 190. We could be running at 200. And so the homeowner is only going to be paying for what they're using, not paying for the 230. That's what makes it efficient. And when your ductwork is on point, and you have your dip switches set for the fan speed on point, and you got good airflow, they're going to see great savings on their electric bill. That's the purpose of the inverter, okay? As a result, you're going to have longer runtime. So you might get a call from a homeowner that's going to say, hey, you know, I think there's something wrong because my unit doesn't shut off. Everyone's used to the on and off from the traditional condenser. The inverter is different. It's not going to have that on and off. It's going to come on and run a little bit longer before it shuts off. The purpose, the longer it runs, what's it doing? It's dehumidifying, and that's what you want. But you're running at, like I said, 190 volts or 200 volts. So it might have a longer runtime, but you're using less energy. And by doing that, our temperature range is almost going to be flatlined as compared to the old system where you had that almost a heartbeat type of temperature swing. That's another reason for the inverter. It is if you know looking at the air conditioning system, all it is one big giant dehumidifier. That's what it is. We're not creating cold air. We're removing humidity, and by removing humidity, that's where you get your cold air, so to speak, or the coolness. By doing that, we need to make this run a little bit longer. And what's going on outside? What's
Somebody else has got something going on, probably.
Oh, okay. The parking lot is full. You should send them over here. Anyway, we have two controllers, and you can use any 24-volt controller. So if the homeowner is happy with their Ecobee, so be it. If they like their Nest, so be it. Whatever they want to use. And you can use that Wi-Fi on that thermostat to operate and download the app on the phone and operate the system that way. The one thing I do want to mention, the difference between the two. There is a more extensive menu on the communicating thermostat that helps you dial in, so to speak, gives you more functions to dial in the system to fit the homeowner's comfort, versus the 24-volt thermostat that's not going to have that same menu.
Is that Wi-Fi enabled? Oh.
That thermostat, no. So we have to get an adapter for it. And so what they're working on now is I told them, don't get an adapter, just make that one Wi-Fi, put the Wi-Fi in the thermostat. So that's where right now the majority are using 24 volts because they want that Wi-Fi feature. Now the one thing I did ask engineering was, if I wanted to use that as a tool, plug it into the condenser, go to the menu, extended menu, and make any changes, will the board accept it and when we take it off? And right now engineering said, no, it won't work. The minute we switch it from communicating back to 24 volts, the board doesn't hold any changes that we did to the thermostat. So they're working on that, on a tool that allows us to plug into the condenser that will give us some troubleshooting details. What are the thermistors doing? What's the compressor operating at? Things of that sort. We have a tool for the ductless product, but we don't have one for the central air product. Okay? But that's the difference between the two. Okay? But what you do have to remember is setting the dip switches to let the system know which controller you're using. All right, it's on both sides. Now, this slide here, I want you to take it with a grain of salt because I asked for technical data to support what they're saying here. They're saying that our unit is compatible with everybody else's. But if there's no technical data to back it up, I don't want you to mix and match. Until I get technical data for you, don't mix and match. Okay? There's places, just coming out of the Florida market, they don't like to see that. I don't know what it's like here, but don't mix and match unless I have some technical data for you. okay? Because I can't tell you what the BTU rating is going to be with our condenser and a carrier air handler. I can't tell you what the BTU output is going to be. So what happens if we put that on with a carrier air handler and it's not, yeah, the system would come on and work, but how's it going to perform? I don't have any data for you. So that's why with this slide, take it like a grain of salt. Just don't mix and match, okay? This is a DC inverted compressor. It's a swing compressor where it swings, it's sideways and it swings like this. A scroll is like this. This compressor swings like this, okay? 3-phase. So when you're checking, if you want to check to see, do I have a bad compressor or whatever, our terminals are right here on the bottom, U, V, and W, right here. This is our compressors. You take those wires off, you check with the wire, you can check it with the terminal, but when you ohm it out, your ohm value should be the same on all 3 legs. On all 3 legs, your ohm value should be the same because it's a 3-phase motor. Okay? Another test while you're running it, if you ever want to know what percentage it's running on, what speed it's running on, so to speak, you measure your voltage coming in, where you make your connection. It could be 240, for all we know. You measure your voltage coming in, leg 1, leg 2, and then you measure your voltage of what the compressor is using. You see it's going to be less. You divide the 2, and it'll give you a percentage of what the compressor is doing. Then you can get an idea of how many BTUs. You can get like a ballpark of what it's doing in that moment. Okay? That's just for your own knowledge when you're doing maintenance, If you're ever wondering, oh, what's it working at now? It's 80 degrees out. What's it doing? It shouldn't be running at 90 or 100% at 80 degrees. It should be running at about 60, 65%. And on a super hot day, you want it to be between 70 and 75%. You don't want it to be running at 90 or 100. It has the capability of going to 103%, 130% of its capacity. But when it gets to that point, you've lost your efficiency. The electric bill is going to go through the ceiling, okay? That's what you don't want. So when you have a properly sized ductwork, properly sized unit as far as BTUs, you should be the ideal between 75 and 80% on the hottest day. That's the best. That's when you know you got it on point. They'll be saving money every day that AC is running, and it'll be working and dehumidifying. Okay, when you build your ductwork, don't build it to the size of the unit. You build it to the size of the opening. All right, you want to maintain that static pressure in your ductwork. Right, you build it to the size of the unit. You got all this dead space here, creating that ED current, and we're losing static pressure. Okay, build it the size of the opening. Okay, and it was mentioned yesterday about hydro coil. If you have the space, I wouldn't put the hydro coil directly on top of this. I would keep at least a 12-inch piece that with an offset, and it to fit to your hydro coil. All right.
Backup heat.
Right. Right. Dual fuel, basically. They'll have a boiler that feeds that. Right. You might need to put an isolating relay, a rib relay to activate the valve for the water to circulate in there. Yeah. But it can be done, but I wouldn't put the hydro coil directly on top of this. Have that offset. If you have the room, put the little build your own little offset and put your hydro coil on top. If you're in that kind of job, that kind of scenario. All right.